solve that, but we're not really super familiar with solving equations that look like this. What we're much more familiar with is when it's all equal to 0. So what I can do is I can move the 23 to the right-hand side, and when I move the 23 to the right, or sorry, 24 to the right-hand side and combine it with the 3, here's what happens. I get 0 equals negative 16x squared plus 88x. And then if I minus 24 from the left, there's a 0. That's why the 0 is on the left. If I minus 24 from the 3, I get minus 21. And now we see a quadratic equation that's just like all of our other ones. And since we've already done this kind of problem 4 times, I'm actually going to show you a different way to do this problem. So I thought I'd show you how to do this particular problem on your calculator since we've already learned how to do it the other way. So I'm going to go into my y equals. You don't have to do this on yours. You can just watch, follow along. So the equation that I saw on the right-hand side was negative 16x squared plus 88x minus 21. Now, if I look at the graph of that thing, and I go zoom 6, hopefully I can see both places where it's hitting. You can see it's hitting the x-axis. It looks somewhere near the origin, and then maybe at about 1, 2, 3, 4, somewhere around 5. Can you guys see that? So I'm going to change my window just a little bit, because this is kind of bugging me. It's kind of spread out. So I'm going to change my window on the x-axis at least. I'm going to start maybe at negative 1, just in case it was to the left. And then I'm going to go to, I don't know, 6. And then I'm going to graph it. And that way I can see the graph a little bit better. And you notice that it's crossing between 0 and 1 and between 5 and 6. Now the cool thing is on your calculator, you have a tool that helps you find the zeros. It looks like this. Second trace, and when you do second trace, it's a calculate menu, and number 2 is find the zeros. So then it'll tell you where the left bound is. That means pick a number that's to the left of where you think it's crossing. Pick an x value. So what looks like it's to the left of where it's crossing? Well, it looks like 0 is to the left of where it's crossing. So I just type in a 0 and hit enter. And then it says, give me a right bound, which means just go to the right of where you think it's crossing. So it looks like it's crossing between 0 and 1. So I'm just going to put down 1 and then hit enter. And then it says guess. And I don't know where that is, so I'm just going to guess at a half. Or in other words, 0.5. And hit enter. And what you find out is it's crossing at 0.25. That's the x value, 0.25. So that's one of my answers. I can do this again to find the second one that's to the right of 5 and left of 6. So I can go second trace, number 2 for find the 0. Where's the left of what I'm looking for? That's at 5. Where's the right of where I'm looking? That's at 6 on the x-axis. Where do I think it's going to be? I'm going to try 5.5. And I find out it's actually crossing at 5.25. Now this tool on your calculator is an awesome way to check if you're doing something algebraically. So make sure you check. So back in our notes, what I know now is that when I solved this thing using my calculator, I found out that my solutions were 0.25 and 5.25. And since I was working in, I believe it was feet per second, way back up here. Was it feet per? Yeah, feet per second. I know this is in seconds. So I know that my ball is going to be 24 feet, the height that is, in the air, 0.25 seconds after I hit it, and 5¼ seconds after I hit it. Because remember, this is a parabola, probably opening upside down, because there was a negative in the beginning. So it looks like this, and what's happening is it's crossing the x-axis in a couple of spots, but it's hitting the 24 feet height in 2 spots. And those 2 spots are 1/4 second and 5¼ seconds. That's what's happening. So in the 4th step, same exact problem really, but instead of saying 24 feet, they're saying 124 feet. So this time I think what I'll do is when I set up the equation, maybe I'll try to do this one algebraically just to show you. So I have 124 feet this time equals my negative 16x squared plus 88x plus 3. If I move that 124 to the other side, I'm going to get 0 equals negative 16x squared plus 88x. And if I subtract 124, that's how I got the 0 from the left. If I take 3 minus 124, it's negative 121. So at this point in time, I could do what I just did with the previous part in step 3, put it in my calculator, find the zeros that way if I want to, or I can use the quadratic formula at this point. So if I use the quadratic formula, my x will be equal to the opposite of b, plus or minus the square root of the b squared minus 4 times the a times the c. What was my c? Negative 121. Holy mackerel. All over my 2 times my a. And as usual, looks like I just ran out of room. So I'm just going to continue into step 5, and then I can do step 5 on a different slide, I guess. As I solve this, I will get negative 88 plus or minus the square root of, and then in my calculator I type in 88 squared. It'll be a ridiculous number, I'm sure. 7,744 minus 4 times 16, which is 64, times negative 121, which is, surprise, surprise, 7744. And that's all over negative 32. So the cool part, I guess, as you're looking at this, is the stuff that's on the inside cancels out. You don't even have to worry about that. And then you just have to take 88 divided by 32. Negative divided by negative would be positive. And my final solution then is whatever that negative 88 divided by negative 32 is, or in other words, 2 point something? 2.75, thank you. And it says we're looking for the time when this happens. So this is 2.75 seconds. And notice how there's only one solution. Why is there only one solution? The discriminant is 0. That's why there's only one answer where that occurs. So the last question here says, write an equation to find the time when the ball reaches a height of 200 feet. And what happens when you try to solve this equation with the quadratic formula? So we're going to try this algebraically again. I'll go to the 3rd slide here. That's blank. And I know that my equation, when I set it up, I want to have the height, 200 feet, equal to negative 16x squared plus 88x plus 3, which was my original starting value. In order to use the quadratic formula, you have to have it equal to 0. So as I start to solve this, I move the 200 to the right-hand side, And when I do that, I'm subtracting off 200, so now I have nothing on the left. I still have the negative 16x squared, the 88x. But now I have 3 minus 200, which is negative 197. And as I set up my quadratic formula, I will have x equals the opposite of the b, plus or minus the square root of the b squared, minus 4 times the a times the c. All of that over 2 times my a. And I know this looks ridiculous, but have no fear, something really cool happens. As I simplify it, I get negative 88 on the inside, or on the outside, pardon me, plus or minus the square root of 88 squared was 7744. Thank you. And then a negative times a negative times a negative means I get a negative. And then 4 times 16 times 197. I get 12,608. And on the bottom I have negative 32. And what I want you to notice is what happens with the discriminant. What do you notice about the discriminant? It's negative. When the discriminant's negative, that means there are 0 solutions. Or in other words, the ball never reaches a height of 200 feet. So kind of the nice thing about doing the algebra, if you're going to use algebra, is you could look inside the discriminant and see if you even have any answers.